In this episode of Voice of the Sea, we're checking out the future of aquaculture at Keāhole Point on Hawaiʻi Island at the Hawaiʻi Ocean Science and Technology Park. We visit 3 visionary aquaculture operations, showcasing the range of industries growing today. We check out Blue Ocean Mariculture, which operates the only open ocean offshore fish farm in the U.S. We visit the Symbrosia farm, which grows limu kohu, a native Hawaiian seaweed, as a supplement for livestock. And we tour the huge outdoor culture ponds, where Cyanotech Nutrex Hawai'i grows microalgae for human health supplements. First, we talk with NELHA Executive Director Riley Saito about the unique facilities at the Hawaiʻi Ocean Science and Technology Park and why over 50 tenants use Host Park.
We're at the Keāhole Point. The state has been blessed with having a facility here called Natural Energy Laboratory of Hawaii Authority. This is a setting for creating life, plant life, animal life. We provide deep sea water, which is 40 degrees Fahrenheit approximately, and that's cold. And you've got surface sea water about 70 to 80 degrees Fahrenheit. And it's a blending of those that can actually create a climate and environment in which various sea life in plant and animal forms can actually flourish and optimize their conditions so that they can be the most productive.
We're at Blue Ocean Mariculture.
We have a hatchery, which is where the process starts, right here. We also operate an offshore fish farm. And then the third big part to this is we also bring the fish on land and then we process it all and then sell it ourselves. This, by the way, is an ice maker.
Oh.
It's a giant shape ice maker. Our sole purpose here at the hatchery is to produce 600,000 fish per year in 4 batches. So each batch takes 3 months to produce, from egg to little juvenile fish that goes out to the cages.
Tell me, what fish are we talking about?
Yeah, so it's Cirrula rivoliana. It's a member of the yellowtail family. In Hawaii, they call it kahala. In Florida, they call it almaco jack, or long-finned amberjack. And then in Japan, they call it kampachi.
How is your farm-raised kampachi different than what we might catch in the wild?
It's taste-wise, it's not too much different. It's a little bit fatter, but because we're in the high-energy environment, it's kind of the differentiation between kampachi and hamachi. So hamachi, usually coming from Japan, is in kind of calm waters. Kampachi has kind of a crispier bite to it because the muscles are more developed from swimming in the strong currents that we have out here. The kahala, that's the Hawaiian term for kampachi. Here, basically in their natural cycle, they'll get a parasite that goes into their flesh, and so because of that parasite, nobody will eat it. That happens actually really when they're really young, eating plankton, and because of all of our fish eat the plankton that we grow in the hatchery, none of them get the kahala worm or the amberjack worm.
This is where the first stage of plankton is produced for the larval kampachi. And here we grow rotifers, which is basically a little protozoan. It's about 200 microns big, about 20% of a millimeter. We carefully monitor and adjust the nutritional components the rotifers are eating, for example, like vitamin C, DHA, EPA. I can go down a list of 30 different nutritional components that we're very carefully regulating to make sure that the nutrition that the larval fish is eating is just right for them. Let's go over to the larval room. These are called larval rearing tanks, and they'll spend the first 35 days of their life in these tanks here. Once the fish are about almost 3 weeks old, they're ready to start weaning. That's what it's called, transitioning from these live plankton diets to a man-made fish food, basically. All these wires that you see going over there is actually streaming live data into a mainframe that's telling us the dissolved oxygen levels, the flow rates, the pH, all these components, pumps that are running, blowers, all the stuff that's necessary to keep these fishies alive is all basically live streamed right now. You can get it from my watch. It allows us to operate this entire facility with 12 people. If you look at basically our overall take of wild fish for our production here, for our brood stock, over the years, we've probably only taken 300 or 400 fish. These wild fish domesticate rapidly. 3 days after capture from the wild, you can feed them from your hand. These guys feel comfortable right away. They'll start spawning as early as 2 to 3 months after capture. Yeah, they like to eat. We're gonna go down below and you have a really good view of the fish from below. Right now, Ari is feeding these broodstock. These guys get fed 6 times a week, once a day, and they're eating a blend of sardines and squid. We also give them a vitamin supplement, which is actually snuck into the squid. So the broodstock will keep growing. I think world record for these guys is about 120 pounds. They get big. These are what are called F1s.
Oh.
So these are 4-month-old fish. So from egg
Oh my gosh.
to 4-month-old. We work with veterinarians to make sure that really what we're trying to do here is develop a very healthy future broodstock. So we want healthy animals. You can see the shape's a little bit different off the domesticated fish. First generation, these fish are not having to escape predators or find their food.
Our system is built for 8 net pens that are about 8,000 cubic meters. Because we're in the really high energy environment, they're subsurface pens. So they sit about 30 feet below the surface of the water. They have to come up and hang out with us for a little bit, but it's only a couple hours a day. But we feed them down there so that it's a nice calm space before we bring the pens up and start checking them out, looking for, inspecting the pens, inspecting the fish. There's a dive team, there's multiple dive teams working every day, one doing kind of feeding, one doing net inspections and mortality, classifications so we know why animals are expiring, if it's all natural, if there's something weird going on. And then we have our operations team that's either doing harvesting or cage installation. So there's always something going on the farm. Right now we're feeding about 10 tons a day. We take the feed and we mix it with seawater, then we send it all the way down to the fish. One of the reasons that aquaculture is sustainable is because of these pelagic fish have really good feed conversion ratios. For every pound of feed that we put in the water, we're getting almost a pound of fish out from that. Versus, in the poultry industry, you could be putting in 3 pounds of feed for chicken to get 1 pound of chicken out of it, or you could be putting, 5 pounds of feed in for pork to get 1 pound of pig. One of the really big draws of this being a socially responsible type of protein to eat is because it's so much less energy going in to get the energy out that we need. Tomorrow we'll take orders for Saturday and we'll go out and harvest exactly what our orders are.
We've got these big tanks here. Each of these is about 40 cubic meters. Each tank has about 25,000 juvenile fish in them. These guys are going to start going out to our net pens hopefully tomorrow.
So how old are these fish?
So these guys are about 3 months. You're looking at about roughly 6 tons of fish right now, of little guys. If you add up all the weight, it's about 6 metric tons of little guys. These will turn into about 300 tons of fish.
What we're trying to do here is help shape the blue economy and change our food systems to be a new industry that's viable for our areas, that creates food security, that gives us back kind of our land and looks at our oceans, and it actually starts to be regenerative to the ocean ecology, at the same time providing healthy food for people.
What is restorative aquaculture then?
Restorative aquaculture is the idea of doing aquaculture in the way that enhances the ecosystems. What I've seen offshore is that these are restorative to fish populations and honestly could create great fishing grounds around them as these species kind of come up almost like as a marine protected area does. The net pens out there are basically just huge fads, and those fads create good larval recruitment. And the more areas there are for settlement, create these new areas for some of these pelagic finfish to grow up to a size where they've got enough protection to then move out and become another fish that could be a wild fishery at some point. We're seeing species out there that today the guy said, hey, there's a bunch of yellowfin tuna swimming around the farm, and they're chasing some of the apello out there. So they're creating this whole ecosystem that didn't exist, much like oil platforms start to create new ecosystems that otherwise weren't there. And some of the fisheries around those oil platforms and now around these aquaculture sites are areas where we're getting new pelagic species that we wouldn't have otherwise had or been able to fish for in the wild capture fishery. There's a net positive to having these types of infrastructure offshore that can help even the wild fisheries be more sustainable.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
You're watching Voice of the Sea. We're checking out a few of the innovative aquaculture projects at Host Park. Here, the science and culture team at Symbrosia has successfully developed methods for growing and processing native limu kohu at scale.
This is the cultivation side of Symbrosia that you're seeing right out here. This is where we produce and cultivate everything that comes out of the lab that'll go into a final processing after we're done here.
And what do you got growing?
Over here, we have limu kohu growing. We grow it and then we feed it to cattle as like a supplement to their food, and that goes on to help reduce their methane emissions. Another benefit to that is it also helps fatten the cows up. We are hoping to feed 1 million head of cattle, I think by the end of next year.
And that's not gonna be their whole diet, right?
Not at all. This is just a supplement to their natural feed that they have.
Why limu kohu?
Researchers initially started looking at seaweed as a feed additive because they noticed during times of drought or famine that farmers would graze their animals on the beach instead of in the field. And they started to see that the performance improved and the animals were like doing a lot better. And so this kind of opened a new field of research, and they started profiling different species until they noticed that also the yields were improving, and then they connected it to the methane. They discovered that seaweeds can reduce methane. They've now profiled probably over 30 different species of Pacific limus to see if they are able to reduce methane emissions, but only this one species, limu kohu, has these special bioactives in it which can create that effects. Wow. It's really only the species that's able to do this. When the cows eat it, it basically intercepts like the formation of methane in the stomach. Instead of burping, now they're able to digest their food a little bit better. It's not just to reduce emissions, but it also improves the health and the overall efficiency of the operations. The last herd that was processed with Parker Ranch, the butchers were saying that they could notice a difference visibly in the quality of the meat. The cowboys were saying that they noticed that they were just like healthier looking, that their coats were shinier. So we get a lot of herbal testimony to the effects that the seaweed is having on the cattle, which is just super cool to hear, because sometimes it's things that you wouldn't even think of, because I'm not a livestock person by training. So I started the company about almost 7 years ago. I was a public health student and saw myself kind of in this innovation sphere, and found that initial research out of Australia that showed that the seaweed had such a dramatic effect. And I applied for like a $300 grant at school at the time and was awarded the grant, and I think we just haven't really looked back since then. Right now we're at 19 people full-time and really have perfected the technology and are starting to scale up production.
Once the limu kohu comes from the lab out to us, we'll have it for about 4 to 5 weeks. And my job is to make sure that they're able to harvest enough to produce for the head of cattle that we're running a trial for. So if we can go around this way, I can show you guys where it starts. When it comes out of the lab, it looks like this. And from here, it'll stay in for about 12 to 13 days. We'll pull spec on these vessels twice a week to see if we need to add any nitrogen or phosphate and trace metals for aquaculture, growing algae. Those are your 3 components. We have controllers on the other side that lets us control the temperature, the pH, and everything just from a click of a button. We have an application on our phone that allows us to change its set points. These limu kohu have been in here for about 3 weeks. So these little limu kohu pups that we have right here are about the size of your pinky fingernail.
Oh.
So then here we have what used to be our final stage of our limu kohu. We have found that there's a sweet spot of about 10 days in this vessel that can double or sometimes triple in the density that's in here. And at nighttime, once the sun goes down, when they're not photosynthesizing or they're not active, they will sink back to the bottom. Up here we have right now, this is our final stage for the vessels. These tanks you see right here are about just under 10 times the size of those black tanks that we were just looking at. These are 12,000 kiloliters.
So does the limu kohu move from the black tank to this tank, or it would go straight from the bag to here?
Straight from the bag out here. Eventually we're gonna have one size bigger than this, and it's gonna be about 90,000 liters. And that's gonna be about 100 feet long by about the same distance wide.
And then would it go straight from the bag into that larger one?
So
Or
it'll
would
go here and then to the larger ones. We can put one of those PBRs in there and it will double in 6 days.
I really see seaweed as an input to multiple industries. We've already have 2 other products that we're working on that can be extracted from the same biomass. We have skincare molecules that we've extracted. We've also extracted the natural pigments from the seaweed, which can be used for textile dyes, food coloring, and also it's like an antioxidant for your eye health.
Can you get all of those products out of the same batch? No way.
So it's basically like replacing petroleum, because you know how when they do like petroleum refining, they refine out all these different fractions of the product, and then that's why everything that you use has petroleum in it. It would be like doing the same thing but with a regenerative biological resource. I think seaweed has emerged as a priority, and trying to find maybe other seaweeds that could be cultured, whether that's for human consumption or other industrial use cases. Hawaii has a lot to gain in the next decade, continuing to develop seaweed innovation. While this is one use case, there are multiple different angles, whether that's from a cultural like Renaissance perspective in the local IA environment using aquaculture, whether that's in a modern research setting like what we're doing, or from a food security perspective as well. And the more people that we can convince to operate in this arena, the more successful that we're all going to be in making this a reality.
How can people get involved or learn more about Symbrosia and the work that you're doing?
For any young researchers or scientists, we have a pretty robust internship program and micro internship program.
What if you've got a bunch of cows and you'd like to be involved? Is there a space for that?
Yes, if you have a bunch of cows, I would also recommend to check out our website, and there's a contact us form where you can put in information that you are a farmer, that you have livestock, or that you're in the industry, and we'll reach back out to you and make sure to make that connection.
We are looking for a few heroes, mentors, trailblazers, innovators, a passion to change lives, spark curiosity, open hearts, and awaken minds, help students answer the question, who am I? This could be your calling, but this is no job. It's the journey of a lifetime. Be a hero. Be a teacher.
You're watching Voice of the Sea. We're at Keāhole Point on Hawaiʻi Island, learning about the many amazing aquaculture businesses operating here. We're at Cyanotech Nutrex Hawai'i headquarters, the largest employer and oldest operating aquaculture business at Host Park.
We've grown a couple different algae over the 40 years or so we've been here, but right now it's mostly Haematococcus pluvialis for astaxanthin, and then spirulina, aka Limnospira platensis, which is just a dried algae, whole algae product.
We have about 44 spirulina ponds here, and they average in about 500,000 liters of media per pond. In total, we have about 30 million liters of spirulina culture media growing at one time.
That's quite a bit.
It's quite a bit. We harvest each pond every 7 days. So they're approximately 20 centimeters deep, and we'll harvest almost to the mat and then re-inoculate and refill, and then another 7 to 10 days we can harvest again.
Spirulina people have been consuming for centuries. It occurs naturally all over the world. The two things that jump to mind are Lake Chad, and there's another soda lake in Mexico. So people have been harvesting spirulina and drying them out as cakes for centuries. Haematococcus is a little bit newer, so animals have been consuming it for as long as animals have been around, but as a dietary supplement, I think within the last, people were probably exploring it maybe 50 years ago, but it's pretty new as far as human consumption is concerned.
And tell me a little bit about the biology of these organisms. What are they?
Yeah, so they're actually really different. They're both called algae, but spirulina is a cyanobacteria, so it's basically a bacteria. Hematococcus is a green algae, which is totally different. It's got a nucleus. It's a eukaryote, which is completely different than a bacteria. It produces a carotenoid called astaxanthin, and that's why we grow it.
And the carotenoid, those are like orange pigments.
Yes.
Orangey red.
Yeah, like beta carotene or lutein. Astaxanthin is one of that class.
And so that's that really amazing reddish orange color I see.
Most of it is astaxanthin. There is also beta carotene and zeaxanthin present, but it's mostly astaxanthin.
Now you mentioned that this is a green algae, but
Yeah.
the color I see is definitely not green.
Yeah, it starts its life out as bright grass green, and then as it undergoes this dormancy phase or encystment, it actually quadruples in volume and turns red. You've seen astaxanthin many places before, even if you're not aware of it. It's the molecule that makes salmon that pretty orange color. Oh. It's also a major component of like flamingo feathers, lobster shells. Hematococcus is often called the bird bath algae. So you may have seen a bird bath with like a red ring around it. It's probably Hematococcus. So it starts out life as this small green cell with a flagella. And as it runs out of nutrients and the pond maybe dries up, it goes into this dormancy state. Part of that dormancy is producing astaxanthin to protect its genome from UV damage. And that's what you see here, is this pond is like getting ready to undergo that dormancy stage.
We sell our product to about 60 countries worldwide. You'll see our bioastin and our Hawaiian spirulina bottled in your local retailer. We're at Costco, we're at all your local health food stores, but we also sell those raw materials to brands internationally. So I work on the international side selling our raw materials to other brands.
How many people work in your company?
We have about 80 employees, mainly farmers. Most of our staff work out here on the farm in our ponds.
And where do your employees come from?
All of our employees mainly are local. We try to hire as much local staff as possible.
How important is algae culture in the world of aquaculture in general?
Yeah, so people don't often realize it, but at least down here at Nelha, pretty much everyone is also an algae grower. So the fish people are growing algae to feed to the rotifers, to feed to the larval fish, and the shrimp people are growing algae to feed to the larval shrimp, and the oyster people are growing algae to feed to the larval oysters. So, you know, growing algae is kind of the foundation of aquaculture.
If you have a passion for microalgae and you're interested in large-scale production of microalgae, we are always hiring. We have positions available in our quality lab. We have production, cultivation staff. We have harvesting staff. We have some very technical positions, and then we also have some general outdoor positions. So there's a fit for everyone.
If people want to learn more about Cyanotech, bioastin, where do they go?
You can just Google bioastin and you'll find us.
Aquaculture is important historically, culturally, and as a growing sector of Hawaii's economy. The businesses at Nelha's host park are building towards a sustainable future for Hawaii. Learn more about Nelha, host park, and innovative aquaculture in Hawaii on our website at voiceofthesea.org. Follow us on social media at Voice of the Sea TV. Mahalo for watching Voice of the Sea. Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org.